For the circuit shown, calculate the total resistance, the voltage across each component, and the current through each component.
Admin D, there's no current shown.
I'll draw it. So, what I think you should do is, after I draw it, and after you see it, after you copy it down, you should try to use those formulas from the last video and see if you can calculate this on your own. Try it first. Okay, so here we have our circuit that's in parallel. If I disrupted, if I broke this off, then the current would just flow on the outside. So like, if I took out this second resistor and had this wire broken, then I would still have power, or I'd still have current flowing through the first resistor and the third resistor. The way that current flows is from positive over. Some splits off and goes through the first resistor, some continues. Some splits off and goes through the second resistor, some continues. And then goes through the third resistor, and then they all start to meet back up and then return to the power source or battery or whatever. So, there's the circuit. You should pause it right now and calculate all of what it was asking and see if you get it right. Yeah? So pause it and then go. I'm going to start doing it right now. First thing it asks is to find the total resistance. Now we have to remember what the total resistance formula for parallel circuits was.
Admin D, I know it.
I didn't ask you, alright?
Oh, okay.
No, but you can say it. That's fine.
Oh, okay, man. That was the one with the fractions.
Yeah, it was. All right. Total resistance. It was in green. I'm going to say the total resistance was 1 divided by, and how many do we have here? We have 3 resistors, so it's going to be 1 over the resistance in the first component plus 1 over, and so on. So that's the formula that I'm going to need to use. Well, that's pretty simple. All I have to do then is write this down and calculate it. I would be using a calculator for this, so I'm going to say RT. The total resistance is 1 divided by 1 over R1. You got to be very, very careful. Take it slow on this stuff, just because if you don't, you're rushing it, you might be able, or you'll do it wrong. If you have a graphing calculator, this becomes really easy. You just use lots of parentheses. But I don't. So, R1, R2, R3, I'll fill those in. So we have this. Now what I'm going to do is I'm going to figure out these and then add them together. If you want me to show you how to do it on your calculator, it can be very, very easy. But I'll have 1 over... I would type in 470 and then hit the 1 over x button, or on some calculators it looks like x to the negative 1. If you do that, it does this fraction for you. That's what I'm going to do, and then I'll write down each of those pieces. So I have this stuff. I actually did all of this in my calculator and I added them up already, but I need 1 over that, so I can push my 1 over x button again, and then it gives me just what it was. Wait a minute. Well, first let's write this down. If you add up all the denominators, or all of these, if you add up all of those, then what do you get? I get that, and then I push my 1 over x button, and I get 346.592 ohms for my total resistance. So that's the total resistance here. Hopefully that makes sense, because you don't have one single path for the current to flow, so it's not going to all be stopped by 3,000 ohms. It's going to flow probably more current through this because this has less resistance. That's a guess. That's what I'm assuming. Remember, resistance is like obstructions in your water pipe. So if you have more resistance, then it's harder to get through that pipe. Okay, that was the first part. Let me put a box around that. That was the first part, the total resistance. Now, the voltage across each component. What was that formula? The voltage. That one's an easy one. If you look at your Venn diagram, that's just V1 equal, actually it was VT equals V1, which equals V2, and so on. So they're all the same. So V1, V2, V3, VT. Maybe I could do 3 equals V3. That's just 15 volts. Did I put my ohms on this one? Yes. So that's super easy. Okay, done with that. We did this part, we did that part, and then the current through each component. Alright, well, how the heck do we find that?
MD, we use Ohm's law.
Yeah, you could use Ohm's law. It's this part. Okay, so I want to find the current through the first resistor. That should be pretty easy. The current through the first resistor, if I'm solving for current, then that's V divided by R. Well, I know that the voltage across the first resistor is going to be 15. We just figured that out. 15 volts. And then the resistance was given. What is it, 470? 470. And this will give me the current through the first resistor. So 15 divided by 470. That equals 0.03191489. I'm going to round that. That many amps. 0.0319 amps. Hopefully that's the biggest one. I think it will be. Just because we have the least amount of resistance in that resistor. So that's the first one, and you can do the second and third just the same way. You're calculating the resistance, no, sorry, the current, so it's just V divided by R for each component. If you haven't done this already, then you should pause it and then do it for this part. Alright, here we go. Here we have all the currents. Yeah, that is just by using Ohm's law for all of that. Now, we did have a formula for current, didn't we? It was the sum of all currents. That was, I think I said that was Kirchhoff's current law. Maybe not. But I want to do something. That law, or that formula was this. We had this. So let's see if that's true. If we take all of our currents and add them together, let's see if we get something that's close to that. I'm just verifying. I'm just going to verify this formula. That was weird. So I'll just say that IT equals 0. What does it say? 0319 plus 0.00618. We'll say amps. Make sure you include your units. Plus 0.0045 amps. And so we'll add that together. I'll do that on my calculator. And then hopefully I get this. Yeah, look at that. I get 0.04258 amps, which is close. The only reason that it's not exact is because I rounded. I rounded these. Okay. Usually I won't round. If I'm doing my own calculations, usually I won't round. That way I get the exact amount. So there we go. That's the example for calculating the components for a circuit in parallel. It's very easy. It's very easy. Make sure you wrote down all of this information. And I think we're going to have a... Oh, well, let me check this off. There we go. It's done. Okay, bye.